So on the previous page, you might ask yourself, why do we care about this? Why did we care about this table of values? Couldn't we just plugged in x equals 1 and gotten the y value? Well, the answer is yeah, on that function, it was what I'm going to call a nice function, where we could have just plugged in x equals 1 and gotten the answer for the limit, which is y equals 2. But let's consider this next example here. It says, consider the function f of x equals x cubed minus 1 over x minus 1. We want to consider this function when x equals 1. Consider if we just plugged in the number 1 here. So we'd have 1 cubed minus 1 on top and 1 minus 1 on bottom. Well, 1 cubed minus 1 would be 0, and 1 minus 1 would be 0, so we'd be left with this 0 over 0. 0 over 0 is called indeterminate form. Indeterminate form. Okay, indeterminate form is undefined. That means the function is not defined. We have division by 0, right? The function's not defined at that point. So just because the function's not defined at a point does not mean the limit doesn't exist at the point. Again, a limit is what happens near a point, not what happens at a point. So we're looking at the behavior of y near it, not at it. So the function's undefined doesn't mean the limit doesn't exist. Okay, so let's look at this. It says we can see f of x is undefined at x equals 1, as both the numerator and denominator would be 0. Again, that's indeterminate form. So the function is undefined when x equals 1, again, because you would have division by 0. But what is happening to the function near x equals 1? To get an idea of the behavior of the graph of f near x equals 1, you can use two sets of x value, one that approaches 1 from the left and one that approaches 1 from the right. So again, our goal is to plug in the number 1. What happens to the y value? Again, my y value here, my function here would be x cubed minus 1 all over x minus 1. That's what I'd be plugging it into. What happens to my y value as my x value approaches the number 1? So if you look what they did, they took the x values 0.75, 0.9, 0.99, 0.999. Quite honestly, I wouldn't have done the 0.75. That's not necessary. So I would have had 0.9, 0.99, 0.999. Those are my x values. Notice my x values are approaching 1. And remember, at 1, my y value was undefined. We know that. We don't care what happens at that point. We only care what happens near the point. Likewise, we would come from the other direction. They started with 1.25. Again, I wouldn't have started with 1.25. That's not necessary. But certainly I would have done 1.1, 1.01, and 1.001. Notice as we move from right to left, we're getting closer and closer to the number 1. So the question then becomes, what happens to our y values? Again here, this is where I would hit table. I would clear the function out. I would hit n over d for a fraction, and I would type in x cubed minus 1 for the n. I would hit the down arrow, and I'd type in x minus 1. It doesn't matter what your start is. It doesn't matter what your change in x is. Make sure you have ask x selected. Hit enter for OK. And then look at your chart. Again, if you're given fractions, what you want to do is go over to the number that is a fraction, hit the double arrow button to convert it to a decimal, and you would have the following numbers. When you had x equals 0.9, you would have had a y value of 2.71. When you had an x value of 0.99, you would have had a y value or a function value of 2.97. 0.999 would have had 2.997. And so what I want you to notice is, as we get closer and closer to x equals 1, what's happening with that number? Well, 2.71, 2.97, 2.997 seems to me that it's approaching the number 3. I'd clear out those table values that I already typed in, the 0.9, the 0.99, the 0.999, and now I'd start from the right, so I'd start with 1.1, then I'd type in 1.01, then I'd type in 1.001. Again, convert those fractions to the decimals, and I would end up with the values 3.310, 3.030, or 3.03, and then I'd have 3.003. Note, as I come from the right here, as I'm coming in, my values 3.31, 3.03, and 3.003 are also going to the y value of 3. So what can I say? From the left and from the right, my y values are approaching 3. I know at that point it's undefined, but my y values are approaching 3. So does the limit exist? The answer is yes. Yes, the limit does exist for this function, and the limit of this function is the y value of 3. The limit exists, but the function does not exist. So it says this is read as the limit of f of x as x approaches 1 is 3, which is proper. Just to give you an idea visually of what the heck just happened, what did we just talk through? Well, here's the function f of x equals x cubed minus 1 all over x minus 1. This is what the graph looks like. And if you remember what an open circle means, an open circle means it's undefined at that point. And notice as I come from the left, my y value is approaching the y value of 3. And as I come from the right, my y value is approaching the y value of 3 as well. So from the left it approaches 3, from the right it approaches 3. Doesn't matter what happens at that point, doesn't matter, it's not defined at that point. I would say near that point the y value is 3. So that's what the limit is. It says this discussion leads to an informal definition of a limit. If f of x, or the y value, becomes arbitrarily close to a single number, in this case we got arbitrarily close to the number 3, as x approaches c, in this case we did as x approaches 1, from either side, the left or the right, actually from both sides is what we need, then the limit of f of x as x approaches c is L. So we would say the limit of this function, in this case as x approaches 1, is 3. And this is how it's written. The limit as x approaches c of f of x equals L.